Chapter 6: Electricity and Magnetism. Positive and negative charge. The charge is the basic unit of electricity. Just the way we have atoms, the basic particle of the matter, the charge is the basic unit of electricity, which is analogous to the mass for the matter. Benjamin Franklin named positive and negative charges. He is the one who named charges as positive and negative charges. Like charges repel and unlike charges attract. In other words, the positive and negative charges, they like each other or they attract each other, and the positive charges repel each other and negative charges repel each other. An object having equal amount of positive and negative charges is said to be electrically neutral. So the whole material which has equal number of positive and negative charges, they neutralize each other and the whole particle or atom will become a neutral charged particle or entity. Electrostatic charge. So look at this experiment right here. In the first picture, it shows a plastic ball held by a string and it is touched by the hard rubber rod. So you can see this gray thing, it is a hard rubber rod and there is a plastic ball which was held with the string. When you take this hard rubber rod close to this plastic ball, nothing happens. The same plastic rubber rod, if you just take it and rub it against the piece of fur, you keep rubbing for like about a couple of minutes and then take the same rod to the same plastic ball, then you will see that the plastic ball will be pushed back. As if somebody pushed back, it will repel. So the reason it is doing that is whenever the rod is rubbed against the fur, the positive charges will removed from the rubber, or the negative charges will be added to the rubber, the hard rubber rod. So because it has excess negative charges, so now the rubber rod became the negatively charged particle. So when you take this plastic rubber rod to the hard rubber rod to the plastic ball, then if you keep it in contact with the plastic ball for a while, all these negative charges will be transferred to the plastic ball. Now we have a hard rubber rod, a negatively charged one, and also a plastic rubber rod which is also charged negative because the sum of the charge was transferred here. So now this became negative and also the rubber rod was already negative right here. So as we already know that the like charges repel, since it is negative and this is negative, they repel each other and it will be pushed back. So this type of charge, we call it electrostatic charge. A charged rubber rod. So if you take the rubber rod and if it has a negative charge, and if you take to the plastic neutral ball, and if you keep it for some time, then the plastic rubber ball will become negatively charged. At the same time, if you take a glass rod, if it was positively charged glass rod, then after a while, then you will see that the plastic ball would have got a positive charge. Now, since the one of the plastic balls is negative, the other plastic ball is a positive, and as we already know that unlike charges attract each other, so both the plastic balls will be pulled together as if they are attracting each other. The process of rubbing the rubber with the fur does not create any change. So but since the rubber rod earlier was a neutral material, but when it was rubbing against the fur, some of the charges from the rubber rod were transferred to the fur, or some of the charges from the fur transferred to the rubber rod, or because the charges of positive and negative charges which were already there as a bond in the rubber rod were separated and they were flown into or out of uh, the rubber rod, so it became a charged element. So as you can see that, so uh, some of the charges, you can see that, like, since it became a negative right here, so it was positive and negative, positive and negative, positive and negative, and now since we rubbed against it, so the positive and negative charges were separated, the positive charges were moved to the fur. So since it will move right here, so the leftover ones are negative. So now this became a negatively charged object. What is a charge? Every substance is composed of tiny bits of matter called atoms, which are composed of three kinds of elementary particles. So the teeny tiny particle of any element or any material is atom. These atoms consist of three much smaller particles, and those are called protons, electrons, and neutrons. The proton is a positively charged particle with the mass of 1.72 times 10 to the power of negative 27 kilograms. The other particle is the negatively charged particle, which is called the electron, which is the lightest particle out of these three, which has a mass of 9.11 times 10 to the power of negative 31 kilograms. The next one is a neutral particle with a mass of 1.675 times 10 to the power of negative 27 kilograms. So the heaviest particle is neutron, the lightest particle is electron, and the positive particle is proton, the negative charged particle is electron, the neutral charged particle is neutron. The structure of an atom consists of a central nucleus of protons and neutrons with electrons moving about nucleus. An atom is electrically neutral since its number of protons is equal to the number of electrons. So in every atom, in the middle part, which is called the nucleus, will have the protons and neutrons in it. And just the way you have sun and all the planets moving around the sun in orbits, the exactly similar way all these electrons move around the nucleus, just the way the planets around the sun. Sun is similar to the nucleus, which will have the neutrons and protons, and just like the planets, you have these electrons. And the atom is usually a neutrally charged uh, neutral particle, because every atom will have exactly same number of electrons and protons. That's why it's always a neutral charged particle. So this is a picture representation. So you can see that in the middle you have something called nucleus. It will have the green particles, which are neutrons, and the red particles are protons. So as you can see that the protons are positive charge, neutrons are neutral nature, and around it are these blue balls, which are called electrons. You can see that they are in the orbits around this nucleus, and this nucleus will hold all these negative particles, because we all know that the positive and negative charges attract each other. So the attraction from this nucleus will keep these electrons in their valencies. Conservation of charge. The net charge in an isolated system remains constant. It means the charge will not be created or destroyed, but it could be transferred from one to other. The coulomb. The coulomb is the unit of electric charge. Electric charge usually is denoted by the letter Q, and the coulomb is the measure of that electric charge. And this is named after Charles Coulomb. The basic quantity of electric charge is 1.6 times 10 to the power of negative 19 coulombs. Coulombs is a huge charge, and in order for on each electron or proton, you'll have 1.6 times 10 to the power of negative 19 coulombs of charge. So in order for 1 coulomb of charge, you have to have 6.25 times 10 to the power of 18 protons. How much of the charge you have on so many number of protons is equivalent to 1 coulomb. In the similar fashion, we already know that the electrons are the negatively charged particles, so we call it negative 1 coulomb. And the 6.25 times 10 to the power of 18 electrons charge is equivalent to 1 coulomb of charge. Coulomb's law. Coulomb's law states that the force between two electrical charges is inversely proportional to the square of the distance between the charges and directly proportional to the product of the magnitude of charges. So let's say that if we have two charges, Q1 and Q2, the attraction force between them or the repulsion force between them is proportional to the product of those two charges, which is Q1 times Q2. And it is inversely proportional to the distance between them. So because it is inversely proportional to the square of the distance increases, the repulsion or the attraction force between them changes drastically because of that square of the distance. So you can see the formula, mathematical equation representation. Since we said the force, it is represented by F, and the K is the Coulomb's constant, and its number is 9 times 10 to the power of 9 Newton meter square per Coulomb square. And you can see that these two are charges, Q1 and Q2, and then R is the distance between those two charges. And whenever you are trying to find out the attraction or repulsion force, if the charges are positive and negative, all you take is the magnitude of them. And based on if they are positive charges, you say it is a repulsion force. If they are negative charges, we call it a repulsion force. If one of them is positive, the other one is negative, we call that attraction force. Forces between electric charges. So you have a rubber rod right here, and you just rub it against the fur and bring it here. Now you have it as a negatively charged particle. So if this rubber ball right here, if this is a plastic ball right here, if it was already a negatively charged one, then if you bring it closer to this plastic ball, then it would be repelled. As you can see that you have about 6 negative charges here, and you have 1 negative charge right here. So when it repel, it is the repulsive force. You can see that it's some amount. But the same rubber rod, again you take it back to the fur, and if you rub it against the fur for a little extra time, now you can see that the charge built on the rubber rod is more. Now when you take the same rubber rod to the plastic ball, it will go with a higher repulsion. So this indicates that the magnitude of the charge is influencing the attraction or repulsion force between two charges. The force between two charges, as this indicated right here, if you have two charges, they repel, and if they are very close to each other, they repel much stronger. If they are apart, then they repel too, but repel in a lower magnitude. And if the distance is increasing, they do repel, but the repulsion force will not be as obvious. And as you can see that the magnitude of the charges is increasing, you can see that as the magnitude is increasing, the repulsive force is much higher, and as they are getting higher and higher magnitude, the repulsion force will be higher and higher.